Okay, paper 3, ladies and gentlemen. Same as before, you can find the bright question at the bottom rather than watching all of these. Okay, 3,107. So it goes units, tens, hundreds, thousands, 3,107, 0, 10. So 3107. 100% on that question, but for completion's sake, I'll do it. 3/10 is a percentage. Well, percentage means out of 100, so we need to turn 3 out of 10 into being out of 100. So we'll multiply both the numerators and the denominators by 10. We get 30 hundredths. 30 hundredths is 30%. M plus M plus M plus M. That's 4M. 4,000 grams into kilograms. We looked at the units of length in the last paper. In this one, we're going to look at the units of mass. So there's basically 3. We've got a kilogram is 1,000 grams, like a kilometre is 1,000 metres. We've got tons. 1 ton is 1,000 kilograms. Kilograms, grams and tons are the only ones you really need to know about. Kilogram is like a litre bottle of Coke, something like that. A ton is like a small car. Anyway, 4,000 grams into kilograms. So if it's 1,000 grams per kilogram, that's just 4 kilograms. We can think of a number line. If I just draw one going from, say, -5 to 10, -5, 0, 5, 10. So -5 is the smallest, it goes here. Then 4, 3, 2, 1. So -2 will go there. Then 1, 2, 3, 4. So 1, 2, 3 will go there. 6, 7, 8, 9. 7 goes there. And 9 goes there. So in order, it goes -5, -2, 3, 7, 9. Okay. It says start with the smallest number. Sometimes it will say ascending instead. I was shocked how many people got this wrong. It shows me how much you're rushing. The vast majority of you are fine with the area, but the perimeter, there was a huge amount of miscounting went on. So area is just asking us to count the number of squares. 1, 2, 3, 4. If it helps, actually, I'm just going to write along. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. That didn't take long, and it guarantees I'm not going to make a mistake. When I'm going around the outside, I've got to measure each length that we go. So that's 1, 2, 3, 4, 5, 6, 7. I'm guessing a lot of people made a mistake by not counting both of them, perhaps. 8, 9, 10, 11, 12. And up this side, 13, 14, 15, 16, 17, 18. The number of people that wrote 17 or 19 or 16 just essentially made a mistake as you were going round. It's really important you don't make mistakes on these easy ones, guys. 1 mark can make the difference between a whole grade. So take your time on the early questions. Just because they seem easy doesn't mean you should rush them. You all know how to do this. You're all good enough to count them. It's just a case of rushing that meant that you didn't get these right. An easier way to do it is it's 3 wide and 6 tall. And that's 6, 7, 8, 9, and then you double that. So 9 times 2 is 18. Okay, on to question 7. So a spinner is something that you twist around. It's going to land. It'll either lie and on a 1, one of these 2 2s, or a 3. So what's the probability that lands on a 2? Well, 50-50 basically, isn't it? Half of them are 2s and half of them aren't 2s. Just going to zoom in a bit more. So 50-50 evens. Half the places it can land are Half the places it can land are 2s, so evens. I've got to write it though. Circling it's not good enough. Choose a word that best describes the probability the spinner lands on a number less than 4. Well, all of the numbers are less than 4. So it's more than just likely, it's absolutely certain. There's nothing else going to happen. So certain. Right, biased dice. That means a normal dice has got a 1 in 6 chance of landing on everything. This time it's got a 0.4 chance or a 40% chance of landing on this. All the probabilities add up to 1. So all we've got to do here is 1 take away 0.4, which gets us 0.6. If you prefer working in percentages, turn them into percentages. It's 100 take away 40%, which is 60%. So your answer could have been 0.6 or 60% if you prefer fractions. 1 take away 4/10. That's 10/10 take away 4/10. That's 6/10 or 3/5. Any one of those answers would have been fine. I'm just going to go with 0.6 because it's the most obvious, but probabilities can be written as fractions, decimals, or percentages, any one of them. Excuse me. Right, quadrilateral, that's a 4-sided shape. 4 right angles and 4 sides of equal length. Write down the mathematical name of this quadrilateral. Well, it's a square. Simply, we've got 1, 2, 3, 4 sides, all equal length, all equal angles. It could have potentially been a rhombus. I mean, that is also a rhombus and a rectangle, but not every rhombus and rectangle is that. So anyway, square. This, a lot of people have forgotten some of the names of solids. We'll do a lesson revising this, but this is a cuboid. A cube is like a 3D square, a dice like we're thinking about in the last question. If it's a stretched cube, it's called a cuboid. Rectangular prism or square base prism also acceptable in this instance, but really we should all know the word cuboid because they'll use it in the exams. Right, the median number of books, that's the middle number of books. Well, I've got this list, I'm going to write it down in order. 1, 5, 7 and 9. I've got to pick the middle number. Unfortunately, there is no middle number, so with the median we find halfway between those two numbers to get there. So the median number of books is 6, even though nobody actually read 6 books. The range, impressed most people remembered this. That's the biggest subtract the smallest. Or 9 subtract 7, which is 2. I don't know why I've written that sum in there. You shouldn't really write your sums in and working out in the answer box. Draw a bar chart to show the information in the table. Now, they're very lenient with this, but there's a few key things to remember. First off, I've got to draw everything the right height, 1, 5, 9, 7. So I need a scale going up the left. It could have gone along the other way as well, with the number of books. I don't need to label every one of them, but I may as well because I'm doing a full job here. 6, 7, 8, 9, 10. Then I need to label what that means. I'll put on a 0 as well. That is number of books read. Number of books read. Now, if we're being precise about this, our bars should always have gaps between them and the axes, and they should all be the same width. So Zemina read 7 books, so I'm going to draw their bar going up to 7. Use a ruler to make it look good. I'm just going to shade it in. You don't have to, but I just think it makes things look a bit more obvious. I'm going to label who it is. That is I could have made that twice as wide. Don't need to. I don't want to waste time colouring things in if I don't have to. Martha, red 9. So Martha's going to be up there. I'll draw hers. I'm using a ruler and taking it seriously. It's our actual GCSE. We may as well do things properly. So that's Martha. We have to label who was who very clearly. Kezia doesn't read very much apparently. You should try reading some books, Kezia. They're good. Kezia, K-Z, K-E-Z-I-A. And Tabby, 5 books. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Tabby. Okay, so bar charts, gap between the bars, bars of equal width. These are things that you should do in bar charts, but unbelievably when you look at the mark scheme, gaps between bars, they condoned having different width ones and no gaps. So actually in this one particular paper you could have drawn practically anything as long. The other key thing is this needs to be to scale 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, not 0, 2, 3, 6, 1, whatever. It's got to be the same scale going up. Okay, took all that, but on to question 10. Generally well done. A good example of people making a few little mistakes in there. So Wayne begins walking at 8:30 a.m. He walks for an hour and 45 minutes. I'm going to call that stage 1. He then rests for 15 minutes. I'm going to call that stage 2. Then walks for 85 minutes. That's stage 3. Does he get there before noon? Well, the easiest way to do that is figure out when he gets there. So start 8:30. Step 1, I'm going to add 1 hour 45 minutes. So I can do that in 2 stages. So actually, do you know what? I'm going to do it this way. Add 1 hour, then add 45 minutes. So 1 hour takes us to 9:30, and 45 minutes takes us, 45 minutes would go, it takes 30 to get to 10, so 10:15. So that's the end of that walk. He rests for 15 minutes, so that's stage 2. I'm going to add another 15 minutes on. So he gets to 10:30. Stage 3, and then walks for 85 minutes to get to a cafe. Well, 85 minutes. That doesn't give it me in hours, so 1 hour would be 60 minutes, so it's an hour and 25 minutes. So I'm going to do the same again. I'm going to add 1 hour, then I'm going to add 25 minutes. So 1 hour takes me to 11:30, 25 minutes takes me to 11:55. So he arrives at the cafe then. Oops, don't know why I've written cafe. Arrives at the cafe then. Oh my goodness. The examiner can work out what I mean there. Arrives at cafe, so yes, before noon. So the key bit here is think about what you're doing. Maybe break down big ones, hour and 45 minutes, into 2 separate stages. Less likely to make a mistake. 85 minutes, turn it into hours and minutes. It makes it easier to add things on in different stages. And then just quick check. That's 1 hour. There's lots of ways you could have done this, but that's 1 hour, 2 hours, 3 hours, nearly 3.5 hours, 3.5. Yeah, okay, so that sounds about right. 8:30 to 11, nearly 12 is nearly 3.5 hours. Okay, Gabriel thinks of a number. He multiplies his number by 5 and then adds 7. His answer is 72. 2 ways of doing this. I'm going to show you the algebraic way first. Gabriel thinks of a number. I'm going to call that x because I'm not that inventive. X. Multiplies it by 5. There, so that means 5 times x. And then he adds 7 and he gets an answer of 72. I've formed an equation I can solve. Take away 7 from both sides. Means I'm left with 5x equals 65. And then divide both sides by 5 gets me x equals 13. I've got a calculator to do that if I need to. But I'm pretty confident I'm right. So what number did Gabriel think of? He thought of the number 13. The other way of doing it is thinking about it in terms of a flow chart. So number, he's going to start with his number. Oops, I'm looking at the screen while writing. And he's going to multiply it by 5, add 7, and then he gets 72. So I now need to go the other way. 72, subtract 7, and then divide by 5 to get my answer. 72 subtract 7 is 65. Divide it by 5 is 13. I get the same answer thinking of it that way. Okay, question 12. Excuse me. Modal. Hopefully, when you see that, you think mode, the most common. What happened the most? It's a guitar exam, and this shows the grades. So there was pass, fail, distinction, merit. They're the 4 different marks that you can get in this exam. So which one happened the most? Well, you can see the pie chart for merit is much bigger than the others. That's the most common. That's the one that happened the most. So merit is the modal grade, or the most common, the mode. 7 students got a distinction. Work out the total number of students who took the guitar exam. What I've told you guys over and over again, when you've got a pie chart, try and work out the degrees per person. If you can work out how many degrees it is per person, we can get there. So 7 students got a distinction, so 7 students is 105 degrees. So let's share that 105 degrees by 7, which I think is going to be 15. 105 divided by 7, 15, yeah. So that's 15 degrees per person. It's not my answer though, that's just, this has been divided up into lots of different sections. So if I can work out how many 15 degrees go in here, and one thing I can do is work out distinction is going to be 7. That's 2 15s, so there's going to be 2 people fail. The passes, how many 15s go into 75? 75 divided by 15, there's 5 people passed. And 150 divided by 15, 10 people got merit. So in total, I add them all together to work out how many there are. 15, 17, 24 people. The other way of doing that, that helps you with pie charts generally, but just the whole pie chart is 360 degrees. So if I divide that, see how many 15 degrees go into it, I also get 24 people, 24 students. The key thing, this degrees per person. Any pie chart question, work out how many degrees, how big is a wedge for just one person. When you've got that, everything else falls into place. Right, Rowena's driving from her home to a beach. So when she's at the bottom, she's at her house. The distance from her home is 0. So she's gone 10 miles away, and eventually has got 35 miles away from her home. So she must live 35 miles from the beach. I can see in terms of time, she set off at midday, and she got where she's going there. I mean, this is a bit easy to understand if I make some marks actually. 1 o'clock, 2 o'clock, 3 o'clock, 4 o'clock, midday. So that's halfway between 1 and 2. So 1:30 she got to the beach. So she set off at midday and got there at 1:30. It's a little bit here where it's horizontal, as in she's not moving, she's not getting further away from home. So that must be a break. So Rowena stopped at a cafe on her way to the beach. That must be where they stopped. So how many minutes did Rowena take to drive to the cafe? So how far to get from there to there. So we're going to identify that that's what it is. So she got there at 12:30. So that must have taken 30 minutes to get there. Write down the distance from Rowena's home to the cafe. Well, loads of you wrote 35 because you'd seen that she stopped 35 miles from home. However, the first stop, the cafe, that's on the way to the beach. Beach is here. Cafe is there. So, distance from Rowena's home to cafe, well, she was 0 miles. By the time she got to the cafe, she was 10 miles from home, so it's 10, not 35. Right, she stayed there for an hour and a half and then drove home, getting home at 4 o'clock. Complete the travel graph. So, stayed at the beach for an hour and a half. So, she arrived at 1:30. 1:30. And add an hour and a half gets me to 2:30, 3 o'clock. 3 o'clock, and she's not moved anywhere. So that's the first part of this question, is drawing a horizontal line to say that they didn't move for an hour and a half. Then what happened after that? I've got that. She stayed, drove home without stopping, so it's going to be a constant straight line, and got home at 4 o'clock. So from there to there. So I can see she set off to get home at 3 and arrived home at 4. Okay, work out the average speed for the journey from the beach to Rowena's home. So that's on the way home. Speed is distance divided by time. It wants it in miles per hour. So what was the distance she travelled in miles? Well, she travelled 35 miles to get home. And the time it took, some people use 60 because you went, oh, it took her 60 minutes to get home. Like I said, leaving at 3, getting home at 4. But because I want my answer in miles per hour, I want the distance in miles divided by the time in hours. 1. So 35 divided by 1, that's just 35. Okay. This threw a few people here. What I want to work out is how much a box costs and how much a bag costs, and I've got to give my answer in pence. A lot of you missed this bit here. It says, move this paper up, it says pence here, and it also says give your answer in pence. That was one of the first mistakes people made. So let's have a look. 120 boxes cost. So boxes cost. I'm going to convert everything into pence. So 120 boxes was 600 pence. I want to work out 1. I've got a calculator, so I can just do it all in one step. Divide by 120. 600 divided by 120 is 5. So that's 5 pence per box. So bag's going to be cheaper, so I'm expecting my bag to be less than 5p. If it's not, I've got something wrong, which wouldn't be the first time in this video. Bag cost. So 270 bags are £10. In case you're feeling a bit stuck, £10, 100 pence per pound is 1,000 pence. Oh, excuse me, sorry, I just sneezed. So 1,000 pence is what that costs. So I want to work out one bag. I need to divide by 270. Divide by 270. 1,000 divided by 270. It gives me a fraction, so I'm going to have to press my SD button. 3.7037. I could write lots of this down, but I know I'm only going to need one decimal place because of that. So I'm just going to go roughly 3.7 pence. So bag, very cheap bags, very cheap boxes. Bag is 3.7 pence, a box is 5 pence. I need to work out how much cheaper that bag is in the box. So just 5 take away 3.7, which gives me 1.3 pence. And you could have done all this in pounds and just at the end converted it back. And that's 3.721 decimal place. I'll just put that in there because it wasn't exactly 3.7 as you saw. It was 3.703703704. But yeah, if you'd done it all in pounds, you could have then converted it afterwards. That would have been fine. But a lot of people put that £1 pence essentially worked out, and that is not an answer in pence correct to one decimal place. So even if you did all that, you've only got 3 marks instead of 4. Okay, on to question 15. More ratio. Great, we've done loads of ratio table stuff. There's red beads and green beads. And so red, green, total. So I know number of red beads. Well, I don't. The ratio is 1 to 4. So that's a total of 5. And I know there's 35 red. So I'm multiplying by 35. I can multiply everything by 35. So green will be 4 times 35. That's 140 greens in there. And the total will be 5 times 35, 175 total beads in the bag. It's a lot of beads. Okay, describe fully the single transformation that maps shape A onto B. I don't have any. I'm going to look around and see if I've got some tracing paper. Okay, I don't have a tracing paper. I do have an envelope, a wallet. So I'm going to try and do this. So first off, we're going from A to B. So I'm going to, if this was your tracing paper, I'm going to trace over A. There it is. Now, most people spotted it was going to be a rotation. Now, wasn't enough on its own for a mark. I need 3 things to define a rotation. First off, I need to say it's a rotation. Then I need to work out how much it's turned and which direction. So the thing that you may remember when you see me do it is trying to put your pen somewhere and twisting it round. So that spot I've used doesn't work. And you can keep going. Eventually you find it's going to be this spot here, 0. And when you twist that from 0, oops, it gets you up to B. So the key point is that 0. That's the center of rotation. So center 0, 0, or we could call it O because the center is labeled O. Next thing, how far and what direction did I move? Well, I'm moving anti-clockwise there, and I move 90 degrees to get to that part. So anti-clockwise 90 degrees. If you wrote rotation and 90 degrees anti-clockwise, you'd have got a mark. If you wrote center 0, 0, you'd have got a mark. So one mark was for getting these 2, and the other mark was for this one. Okay, this was mixed. Your accuracy varied. So a bearing is 65 degrees. So that's from the north, 65 degrees. Most people remembered that. Then when you're using this, make sure your cross is directly on there. And make sure I'm not quite lined up well enough there. I've got to get that absolutely perfectly lined up. There we go. And then go from your 0 round to 65 degrees. I'm going to put a little mark where the 65 degrees is. And then I need to draw a line that's going over that. And I need to make it exactly, because it's 55 kilometres. It wants to scale of 1 centimetre to 10 kilometres. So I need to do 55 divided by 10, so I'm going to need to make this 5.5 centimetres long. Measuring that as accurate as I can. You don't need to draw this line, but It's going to help me to put my big cross there. That's the town. Town R with a cross. Great. Oh, I did my cross a different way around to that. I'm sure they'll forgive me. I'm just going to write an R so that they're more likely to forgive me. So be really accurate. That's your 65 degrees there. Clockwise from the north. Bearings always clockwise from the north. If it was 125, I'd have gone right round to here. If it was 270, right round there. And be really accurate within 2 millimeters with this. Okay, solve it. There's a couple of ways to solve these. The way I've been showing you, when you see some brackets, just expand them every time. 4 times 2x is 8x. 4 times minus 3 is minus 12. And I get 20. So I haven't sort of done anything to this equation yet. I've just changed the way that first bit's written. Now I want the x on its own, so I'm going to add 12 to both sides. So I get 8x is 32. Finally, I need to divide both sides by 8, so I get x equals 4. Worth checking when you've done these, putting them back into the equation. I checked on these on paper 2 and realised that I've made a mistake, so let's try it. What if x is 4? So then I do 4 lots of 2 times 4, take away 3, and see what that equals. So first off, I've got to do the brackets. 2 times 4 is 8. Take away 3 is 5. So I'd have to do 4 times 5. Oh, look, magic. It gives me 20. I got it right. Great. It is 4. I'm just going to put check here. Right. Simple interest is a weird thing. It doesn't really exist in real life. But what it means is that you're going to get the same amount of interest every year. So however much Jenny's getting, whatever the Y percent is, say she gets 10% a year, that means 10% of this is 300, so she gets 300 every year. It doesn't compound. I genuinely don't know many examples this exists in real life apart from a maths exam. Right. But it tells us after 6 years she's received £450 of interest. Work out the value of Y. So first off, I'm going to work out how much interest she's got per year. So over 6 years, 450 over 6 is £75 per year. So she's getting £75 per year. So I need to work out what £75 is as a percentage of 3,000. Now, if you can remember the way, like the easiest way to do this is 75 over 3,000 times by 100. So 75 divided by 3,000 times by 100. She's getting 2.5% per year. Oh, I don't need to put the percent actually, but I'm not going to lose marks for it. If you have been doing table methods for so long, and let's have a look at this. £3,000 is 100%. And I need to get down to somehow 75%. So I need to work out how to get from 3,000 to 75. 2 ways of doing it. Probably the easiest, because we've got a calculator, is go via 1. Divide it by 3,000, times it by 75. Divide by 3,000, times by 75. So 100 divided by 3,000. Oh, that's ugly. 0. I can't be bothered to write that down, but I don't actually need that one. That's just my sort of halfway mark. So I'm going to take that and just times it all by 75. Oh, look at that. I got 2.5% again. So if 3,000 is 100%, 75 must be 2.5%. Simple interest. Simple interest is where you get the same every year, not real world interest. Compound interest, each year you get a little bit more than the last. Okay, we really need to work on our algebraic things. So the rule of the indices here is when they're in brackets, meaning you times these together, so it's going to be the same as m to the power of 2 times 3, which is m to the power of 6. If you want a little reason why, when you cube something, it means times it by itself 3 times. And the rule when you're doing multiplying powers is you add the indices, so that would be 2 plus 2 plus 2, which is 6. And that helps me answer this one. I've got to add these indices. 5 plus 8 is 13. Okay, for this one I've got to do 2 multiplications. I'm doing 4p times p squared and 4p times 3p. 4p times p squared is 4p cubed. And 4p times 3p. 4 times 3 is 12. P times p is p squared. I just realised I've rushed through this first one here. P times p squared, same rule here. When you've got a p on its own, that's got an index of 1. So I'm adding together 1 and 2 to get the 3. And here, that's p to the power of 1, p to the power of 1. Add together the 1s, gets me the 2. Multiply the coefficients, add the indices. So these are my 2 things. Let's put them together. So I got 4p cubed, add 12p squared. 1 mark for each of those 2. Right, Johnny's coffee, generally well done. Some people lost track of what they were doing, and I think the best way to deal with losing track of what's going on is to keep write down what each number you find means. You don't have to make it all some big mystery. It doesn't take long to add a little bit, and it will help you keep track of what's going on. So 68% of people will drink coffee. So 68% of 800 people. A lot of you have forgotten how to do, because we've done so much work on these without calculators. It's 800 times 0.68. So 68% of people is 544 people. If you can't remember the multiplier method, I mean, it's very good if you can, very, very useful if you can, but if you can't, people percent, so 800 people is 100%. If you just find 1%, that means dividing by 100. So 1% of people is 8, and then I want 68 of them. That means times by 68. So let's just do that on here. 8 times 68 gets me, again, 544. So if you prefer the sort of table method, use that, but don't forget you have a calculator. You don't need to find 50% and 10% and then add loads of different bits together. Just find 1% and multiply it by 68 or 72 or 35, whatever percentage you have to. If you've got 1%, that's your magic number, and you just multiply it on your calculator. So first off, what have I done? Why did I find 68% of these? Because that's 544 people will drink coffee. At least that's Johnny's assumption. 554 people will drink coffee. Then 2 cups of coffee each. So 2 cups each gives me 544 times 2, which is 1088. Again, I'm going to write down what that number means so I don't forget. 1088 cups of coffee. Next, it's 10.6 grams per cup. So if I want 1088 grams, cups, 10.6, that means I'm going to get 11,532.8 grams of coffee, nearly 11.5 kilograms basically. But finally, give your answer to nearest grams, so 11,533, 2 rounds up, grams of coffee. Actually, he's wrong. 72% of the people drink coffee. How does this affect your answer to part A? You don't need to do too much here. It's 1 mark again. They've left 3 lines because some of you guys do like to write massive things, but that doesn't mean you have to fill it. What will this do? How will this affect the answer to part A? My answer will get bigger. That's it. I don't need to say how much. I don't need to say by what percentage or anything like that. He'll just need more coffee. If more people are going to drink, actually, he'd get more people. Sorry, he'd get more people. He'd need more coffee. Okay. We will be running through these, but first off, give a reason for each stage you're working. I hate to see it. You hate to see it. But this is 5 marks. It's going to take us a few minutes to write this down. We've got to figure a few things out. I'll explain what I'm doing as I go, but I like to literally divide the page up. Maths, reason. It helps me write down what I'm doing as I go along. So I'm trying to prove this is an isosceles triangle, which means triangle ACD. So I've got to find these angles here. I can find these 3 angles here. Then 2 of them, hopefully, will be the same unless I make a mistake. So I need to find all 3 of these angles. So first off, this is an easy one to find, some low-hanging fruit. That's 70. So 110 take away 70. No, sorry, 180. The reason I got that is because there's 180 degrees on a straight line. 180 take away 110 equals 70 degrees. So angle ADC is equal to 70 degrees because angles on a straight line sum to 180 degrees. There's my angle. That's my first fact. I found one of the 3 angles. I won't need to find 2 more. So this one I can't work out straight away because of these parallel lines. If I can figure out this one, I'll be able to work out that one. So this one, same as that, 180 take away 125 gives me 55 degrees. So angle, I'll call this CFG, is equal to, what did I say, 55 degrees. Because angles on a straight line sum to 180. I've squeezed it into a smaller space there because I've realised I'm going to run out of space quickly. Right, so I've figured out those angles. Then, parallel line rules, these are corresponding angles, like the sort of F angle. You can kind of see, and maybe it makes more sense this way from you. Basically, around 2 parallel lines, all the acute angles are equal to each other. That one, that one, that one, or the obtuse angles are equal to each other. Either way, this is going to be 55 degrees. So I don't really even need any mathsy bit for that. I can just write ACD is 55 degrees. Corresponding is a keyword. If I get that, I've got this. Corresponding angles on parallel lines are equal. Okay, so the final angle I've got to work out is this one up here. And this is, I can just think of this little triangle at the top here, and I need to work out what's missing. So I'm going to do 55 plus 70 is 125. Then angles in a triangle are 180 degrees, so I'm going to do that, take away that, which gets me 55 degrees. So that one's also 55 degrees. So that's CAD is equal to 55 degrees. And the rule I used there was angles in a triangle sum to 180 degrees. I'm almost done. Right, I had to show that it was an isosceles triangle, so the final thing I need to do is just say this angle and this angle are the same as each other, so that's ACD is equal to CAD. ACD, so that's that angle. CAD is the one in the middle, is the one I'm looking at each time. They're equal to each other. ACD, that's the triangle. I put the little hat on at this to show that it's an angle. ACD is isosceles because two of the angles are equal. It's not simple. Some of them you can. I've been saying in a lot of these questions, take your time, but and set them out. And in others, I've been saying you don't need to write much. It's only worth 1 mark. Any mark with angle, any question with angles and showing a reason for each stage of your working is gonna take some time if you want to do it properly. You're gonna get fed up when you see this. You're gonna get fed up of doing it. The reason we do it is because it's really important. In looking at maths, we justify every step of what we do. This is what maths is based on. We still want to teach it now because it's so important. You might not care about that. All you care about is getting all 5 of these marks in the GCSE, and to do that you've got to spell out every step of what you do and make sure you can't, each reason has to be mapped to the sort of maths and decision you've made. You can't just do a load of maths and then write a ton of stuff, reasons on the side randomly that aren't matched together. The mark scheme specifically don't allow that. Okay, long question. I wonder if that took me less than 5 minutes. I'll find out. 5 marks should be about 5 minutes. Right, this through a few people. It takes 14 hours for 5 identical pumps to fill a water tank. So there's 5 pumps pumping water in all the time. Lots of people went and decided, and it's a good idea. How long would it take 1 pump? Now, this is what's called inverse proportion, where it doesn't mean that fewer pumps will be faster. Fewer pumps will take longer. It will take 5 times as long if you've only got 1 pump working. Just think about if you're running a bath and you had 5 massive taps on it, you turn 4 of them off, it's gonna take longer. 1 pump will take 5 times 14 hours to fill it in. It'll take, which is 70 hours. If you just have 1 pump doing it, it takes 70 hours. From here, it's a bit easier. 2 pumps would take half that. 3 pumps would take a third of that. And in this case, what it's asking is how long will it take 4 pumps? Well, that will be 70 hours divided by 4. So getting to 1 pump is still an important thing, just like with direct proportion questions. Just this time you get there by multiplying. So 1 pump is 70 hours. 4 pumps will be 70 over 40. 70 over 4, which is 17.5 hours. You could write 17 hours, 30 minutes, whatever. 17.5 is fine. The key bit being it takes long with one pump. Stop and think when you've got some of these logic questions about whether your answer makes sense. If you got an answer that was less than 14, something's probably gone wrong, because 4 pumps cannot do something faster than 5 pumps. Okay, HCF and LCM from this. The way I taught you this, guys, was using a Venn diagram. So we draw 2 nice big circles, one for the factors of A and one for the factors of B. Now we can see there's 2 2's in A and no 2's in B, so I'll put those 2 2's there. Done them. Now in terms of 3's, there's 4 3's in A but only 2 in B, so 2 of my 3's are going to go here in the middle. So that's those 2 there in both A and B, but then 2 more there. So in A so far I've got 2 2's and 1 2 3 4 3's. In B so far I've just got 2 3's. Now the 7's, there's a 7 in both of them, but an extra 7 in B. So let's just check. A should be 2 squared, 3 to the power of 4, and 7. And B should be 3 squared times 7 squared. Now I don't need to work out what these numbers are, but for these big HCF and LCM ones, the HCF is just the numbers in the middle multiplied together. This part here, I'm trying to shade that in lightly with a pen. I don't think this plan's going to work. Done worse. Right, so that's 3 times 3 times 7. 3 times 3 times 7, can do it on my calculator, but I just know it is 63. So 63 is the HCF. So for the HCF, you do the middle. For the LCM, you multiply every number in the whole thing by itself, which is different to multiplying all these together, because some of them have sort of appear in both. But I'm going to do 2 times 2 times 3 times 3 times 3 times 3 times 7 times 7. I'm not going to try and do that in my head. I'll make a mistake. 2 times 2. Move that down. That's that one and that one. Times 3 times 3 times 3 times 3 times 7 times 7. There are other ways of doing this. That's the one I've taught you, so I'm putting it on there. But I get 15,876. I should write down the sum I just did as well up here for them. 2 times 2 times 3 times 3 times 3 times 3 times 7 times 7. Okay, that gets me 15,876. If you're still feeling a bit unsure about this, watch HCF and LCM on Sparks. Generally well done, this one. Some people missed what dividing by 60 or something like that. So again, this exam technique that I mentioned, some of the other questions, write down what your number means each time as you do it. So it's going at 11.9 meters per second. So what a lot of people did to start with was 67,205,600. They took that and they divided it by 11.9. Smart move. It's a really good way to start. 67,205,600 divided by 11.9. Right, and they got 5647529.412. Note how I'm not rounding to, sir. So 5 million watts. Well, that was meters cubed, and that was meters cubed per second. So that means it's going to take 5 million seconds for this lava to come out of there. Now I need to get from seconds up to days. So I'm going to have to divide this more and more and more. I'm going to divide it first by, if I know seconds, I can divide it by 60 to 5 minutes. I'm going to take that answer, divide it by 60. And I'm going to leave, I wouldn't necessarily write down this whole lot for every step. But 5, 9, 2. But I'm going to write down everything on my calculator for the sake of you guys. I wouldn't write down anything more than this number of minutes because the whole thing's going to get rounded. But that was seconds, that was minutes. Next, it's going to take 60 less than that. 94125.4902 over 60 to give me the number of hours. That's 1,568.75817 hours. Great, if I know the number of hours, how many hours are there in a day? 24, so 817 over 24 gives me 65.36 and some other stuff days. It says round it correct to the nearest day, that would be 66 days. Just going to double check what I've done. 205 600. Right, first off I divided by 11.9, then I divided by 60 to get the minutes, then I divided by 60 to get the hours, then I divided by 24 to get the days. Oh, I just don't know why I rounded it to 66 and not down to 65. Well, I got all the maths right and then just got the would have lost 1 mark there. 65.36 rounds down to 65. So last question, oh no, a few more. Here's the graph of y equals x squared minus 2x minus 2. Write down the coordinates of the turning point of the graph. Well, the turning point is this bit here. It's where it stops going down and starts going up. So the turning point here, well, the x coordinate's 1. I'm going to draw this on there to show you what I'm doing. And if I go across, it gets me to 3, negative 3. 1, negative 3. Write down an estimate for one of the roots. Well, could I either estimate that one there or that one there? They're the roots. So I'd say this one here. 1 is there. I think it's just a little bit under 1. Negative 0.8. I can't remember what the exact margins were for that, but either something like 2.8 or negative 0.8. It was difficult to read the way they've labelled this. They haven't put what I'd call, the tick marks on there, but it's worth thinking that each one of these squares I can pretty much tell 1, 2, 3, 4, 5, so that's 3 there. So anyone putting 3 would have gone too high, and 1, 2, 3, 4, 5. It's just the right of minus 1, and it's just the left, well, quite a bit to the left of 3. I'm just going to put the other one there. 1, 2, 3, 4. About 2.7. Don't give both of them yourself. I've just put that there because I needed one. Work out the mass of the cube density. Right. So, if you can't remember what density is measured in, it's grams per centimeters cubed. That's a mass divided by a volume. Density is equal to a mass divided by a volume. Or if I draw the triangle, like that. It wants me to find me a mass, cover up the m. Mass is equal to density times volume. So I've got a density and a volume, so I've got to times them together to get the mass. 9 grams per centimetres cubed, and there's 72 centimetres cubed, so 72 times 9, 648 grams. Right, I've got massive numbers here. I've got to write in the form 1 to n, where n is an integer. So I can think of this. I'm basically going to have to divide by that 9 times 10 to the 4, or 9 times 10 to the 4. If you remember your standard form, it's just 9,000. But you could write 9 times 10 to the power of 4 into your calculator, and it will just tell you. Oh, sorry, I say 9,000. I mean 90,000. It will just tell you. So I'm going to divide both sides by that amount, so that I get 1, and we'll see what we get on the other side. It doesn't say how we need to give it, so I'm just going to type it into calculator and see what I get. So I'm going to do top. I've got 4.5 times 10 to the power of 6, and I'm going to divide by this 90,000. Just for the sake of writing it properly, I may as well divide by this times 10 to the power of 4, which gets me 50. It's 1 to 50. 1 to 50. 1 to n means the left hand side needs to be a 1, the right needs to be a 50. If it helps, this is just a table. That to that, I want it to be a 1 on the left, so I divide by that. Okay, writing these in order of size. The easiest way to do these, and I've staggered some of you managed to do this without any indication of it, is to work out what they all are as actual numbers. Times by 10 to the power of 4 means I'm going to move the decimal point 1, 2, 3, 4 times, so this will be 56,250. That's 5625, obviously smaller than that so far. That's 56,250 times 10 to minus 3, so I'm going to making that smaller, 1, 2, 3, so that's 56.25, minus 3 moves the decimal point left, and times this by 10 to the power of 5, 1, 2, 3, 4, 5, so that's 562.5. I can either write these converted numbers, or I can write the originals. I'm going to write the originals just because most of you did that. So start with the smallest. Well, I think that's 56, isn't it? That one's in the thousands, that's in the 10,000s, that's in the hundreds, so 56.25. This one will be my smallest. 56250 times 10 to the power of minus 3. Number 1, big comma. So I've done that one. Next biggest, that's in the hundreds, so it'll be this one, 0.005 times 10 to the power of 5. Now even bigger than that is 5,625. Even bigger than that is 56,250. And there we go. Right, thanks very much, ladies and gentlemen. Like and subscribe because it makes Harry happy when I say that. But well done. We've got this one finished. Days until the next mock and the actual GCSE getting shorter, but we've got a fantastic base of stuff to learn from here. Hopefully this will have a real impact. Okay, thank you for watching. Good luck.